Hello, if you're watching this video, you are probably taking part in the second sprint week of the year for AP Calculus in Mr. Slaney's room. In this homework, I just want you to get some reps writing solutions to mean value theorem problems. Let's not forget what the mean value theorem says. Mean value theorem says if f of x is continuous and differentiable on a to b, that's an interval, then there exists a value c, where c is in between a and b. This, I don't know what that little foot is. I guess this gradient sign will have a foot. Value c, a is less than c is less than b, such that f of b minus f of a over b minus a equals f prime of c. So this is the strict wording of it. You likely recognize this as the average rate of change of f of x. So the average rate of change of f of x on the interval a to b, just the good old slope formula. Notice no derivatives. And we're saying that the average rate of change will be equal to the instantaneous rate of change at some point. There's a lot that I could say about that. But this should look familiar. Today, I just want to explore how is this tested on the AP Calc exam. This is historically worth, I was looking at my database, and I think on 17, 18, and 19, in the 2010s, there was a problem on here. The math here is very simple. There's consistently been a problem worth 2 points that you can score, and it's pretty mechanical. So I just want you to get some reps on it tonight for your homework, and I just want to show you exactly what that will look like. All right. And what the problems look like, because they're a little predictable in the open response at least. Let's get that out of the way. Here is the 2017 AP Calculus AB free response questions. This is question 6. This is a non-calculator section. Is that showing up? And for the question that we're going to be working with, we're going to use this g of x as tabular function. Let g of x be a differentiable function. The table above gives values of g and its derivative g prime at selected values of x. Notice that the its is a possessive. We're not actually using the noun it, because you know that if you do that, I would chop off your fingers. Maybe. The question that we're going to answer is D. Is there a number C in the closed interval -5 to -3 such that g prime of c equals -4? And let's just, let's take a look. So x is -5 and x is -3. And we see that the derivative here goes from -3 to +4. So it almost feels a little, odd, right? If you just look at that gap, the derivative goes from -3 to +1. No, -3 to +4. So we don't have a guarantee intuitively just by looking at the derivative that we will hit -4. However, let's use the mean value theorem. And initially our thought should be, hey, let's look at g of -3 minus g of negative 5 over negative 3 minus negative 5. Notice my very careful use of parentheses there. These are functions. Here I'm doing negative 3 minus negative 5. That should bring you back to your long division days with polynomials, and that should be a headache. And right now, let's just pull these values. G of negative 5 is 10. G of negative 3 is 2. So I get 2 minus 10 divided by this is 2. 2 minus 10 is negative 8 divided by 2 equals negative 4. All right, so this should work, right? That's just the math. If you get this far, just this is worth 1 point on the AP Calc test for the problem that we're looking at according to the scoring guide that the College Board released. But now we actually have to answer the question because math is all about reading and writing. Is there a number C on the closed interval negative 5 to 3 such that G prime of C is negative 4? And notice, I don't know an equation for G prime. This is a tabular function. But they also could have asked us to do this analytically with equations or solve it, analytically would have been a little bit easier because then we just plug in those x values. All right, so how do we answer this? First thing that we want to write, anytime that you are told that something is differentiable on the AP Calc test, you should automatically just write, I'm going to need to say that G is continuous. G of x is differentiable. I literally have the words in front of me. What's wrong with me? Differentiable. So G of x is continuous. And now, by the mean value theorem, there is some C and let's see, negative 5 is less than C, which is less than negative 3. And you know what, I'll say it, I had to be a little careful. We got a lot of negatives floating around. You want to position this so that C is the value in between negative 5 and negative 3. You don't want to, do something silly like, let's look at if this were reversed. Like, look at that silliness. This implies that C is greater than negative 3, but also less than negative 5. This is an uh-oh, right? This says that you don't know how to write and that you don't know how inequalities work. Don't do this. Also, don't use pen because, you're students. That's why we have pencils. But if you're a YouTuber and you're going to be famous, then you can use pen, I guess. Anyways, by the mean value theorem, there exists a value C. C is in between negative 5 and negative 3. Such that G prime of C equals negative 4. Because keep in mind, they can see this math up here. They want to see this connection. All this is worth 1 point. This is worth 1 point. This is not a high brain power problem. You just got to know the script, right? The function's differentiables, G of x is differentiable, so G of x is continuous. By the mean value theorem, there is some C. C is in between negative 5 and negative 3, such that G prime of C is negative 4. So let's just take a look again at the question. Is there a number C on the closed interval such that G prime of C equals negative 4? We said yes, right? There is some C. And then everything else here is the justification, right? Justify your answer. It's not enough just to say yes or no and show the math. We need to write. All right. Have fun on your homework.